I am Dr. C. Christy, Assistant Professor, Computer Science Department from St. Joseph's College of Arts and Science, Autonomous, Cuddalore 1. This video, let us see about addition and subtraction of signed magnitude data. This video consists of the following contents: addition and subtraction, addition or subtraction algorithm, hardware implementation. Here we will see the definition of addition and subtraction of computer arithmetic. Addition and subtraction with signed magnitude data designate the magnitude of the two numbers by A and B. When the signed numbers are added or subtracted, when two equal numbers are subtracted, the result should be plus 0, not minus 0. This is the algorithm for addition and subtraction of signed magnitude numbers. Here we are having 4 addition operations and 4 subtraction operation details. If both the results are same, we have to go for add magnitude. There is no comparison. If the signs are different, we have to go for subtract magnitudes. There we have to compare when A is greater than B, when A is less than B, when A is equal to B. If A is equal to B means B is subtracted from A and the result is plus 0. Here the first operation plus A plus B. Here both the signs are same. So we have to add A plus B and we have to take the sign of plus. There is no comparisons. The second operation plus A plus minus B. Here the signs are different. So we have to go for subtract magnitudes and we have to go for comparison when A is greater than B, less than B or equal to B. If A is greater than B means B is subtracted from A and we have to take the result sign of A, that is plus. When A is less than B means A is subtracted from B and finally we have to take the sign to the result as B sign, that is minus. If it is equal means B is subtracted from A and we have to take the positive sign. The third operation minus A plus minus B. Here also the signs are different. So we have to go for subtract magnitudes. When A is greater than B, B is subtracted from A and we have to take the sign of A, that is negative. When A is less than B, A is subtracted from B and we have to take the sign of B, that is plus. If it is equal means B is subtracted from A and we have to take the sign plus. The fourth operation minus A plus minus B. Here minus into plus is minus. So both the signs are same. So we have to go for add magnitude. A plus B, that is A and B are added and we have to take the common sign minus to the result. Next we will see the fourth subtraction operation. First operation plus A minus plus B. So here both the signs are same but we are having subtraction operation. So we have to go for subtract magnitude. When A is greater than B, B is subtracted from A and we have to take the A sign to the result. When A is less than B, A is subtracted from B and we have to take the sign of B to the result. A is equal to B means B is subtracted from A and we have to take the positive sign to the result. The next operation plus A minus minus B. Here minus into minus is plus. So both are having same sign. So we have to perform add magnitude. A and B are added and we have to take the sign of plus to the result. Minus A minus plus B is the third operation. Here minus into plus is minus. So here also both magnitude A and B are having same sign. So A plus B are added and we have to take minus sign, that is negative sign to the result. There is no subtraction magnitudes, there is no comparison. The last operation is minus A minus minus B. Here minus into minus is plus. So both the signs are different. So we have to directly go for subtract magnitudes. When A is greater than B, B is subtracted from A, and we have to take the sign of A to the result, that is negative. When A is less than B, A is subtracted from B, and we have to take the positive sign, that is B's sign to the result. When A is equal to B means B is subtracted from A, and take the positive result sign to the result. Next, we will see the addition and subtraction algorithm details. When the signs of A and B are identical, add the two magnitudes and attach the sign of A to the result. When the signs of A and B are different, compare to the magnitudes and subtract the smaller number from the larger. Choose the sign of the result to be same as A. If A is greater than B, the result to be same as A. If A is less than B, the complement of the sign of A. If A is equal to B, if the two magnitudes are equal means subtract B from A and make the sign of the result positive. This is the hardware implementation diagram for addition and subtraction. Here we are having A register. The A values corresponding sign will be stored in AS register. B register, the sign will be stored in BS register. So A and B values are stored in corresponding registers. That is, A value will be put into A register, sign will be put into AS register. B value will be put into B register, that corresponding sign will be stored in BS register. Here we are having complement and parallel adder, that is a combinational logic circuit. These can be performed addition or complement operation based on the mode. The final result will be stored in A register, and A sign will be stored in AS register based on this combinational logic circuit operations. If there is any output carry, that will be stored in E register. If any overflow occurs, that will be stored in overflow register. Here we will see the implementation of hardware in details. It consists of registers A and B and sign flip-flops AS and BS. Subtraction is done by adding A to the 2's complement of B. The output carry is transferred to flip-flop E, where it can be checked to determine the relative magnitudes of the number. The add overflow flip-flop AVF, that holds the overflow bit when A and B are added. The A register provides operations. It needs an addition constitutes of an overflow if it is equal to 1. The value of E is transferred into the add overflow flip-flop AVF, that is add overflow flip-flop. This is the flowchart implementation of hardware algorithm for addition and subtraction of signed magnitude. Here we are having two different flow for addition and subtraction. This is the add operation, this is the subtraction operation. In add operation, two magnitudes A and B will be stored in augment in A, added in B. Here we have to check the signs of A and B using exclusive OR operator. If the signs are equal, that is AS is equal to BS, we have to add A, B magnitude. Result will be stored in A. If there is any carry, that will be stored in E. If there is any overflow in carry register E, overflow that will be set to overflow. Finally, the result will be stored in A register and sign will be stored in AS flip-flop. If the signs are different, that will be directed to the subtraction flow. Here we have to perform 2's complement subtraction, that is A plus B bar plus 1. The overflow register is set to 0. Here there is no carry. In subtraction operation, two magnitudes A and B are used. Minuend is stored in A and subtrahend is in B. Here also we have to compare A and B magnitude signs. If the signs are different, we have to direct this flow into add operation. Here A and B are added. Final result will be stored in A. If there is any carry, that will be put into E register. Here the overflow in E register is set to AVF. Finally, the result will be stored in A register and sign will be stored in AS flip-flop. If A and B signs are same, here we have to perform the 2's complement subtraction, that is A plus B bar plus 1, that is stored in A register. If there is no carry here, if it is any carry, that will be stored in E. Here the overflow register, that is the AVF is set to 0. In addition operation, if the signs are different, the flow will be directed to this 2's complement subtraction. Here we have to check the carry overflow. If it is equal to 1 means A is surely greater than or equal to B. Here once again we have to check A. If it is equal to 0, A sign is assigned to 0. That is positive. So final result will be stored in A. Sign will be stored in AS flip-flop. If it is not equal to 0, the flow will be directed to here. That is result will be stored in A and we have to take the sign of AS. If E equal to 0, we have to compare A is less than B. So here the 1's complement of A is assigned to A. And add 1 to A. Final result will be stored in A and we have to take the sign of complement sign of A to final result. Here the result will be stored in A register and sign will be stored in AS flip-flop. The detailed description of hardware implementation. Two signs AS and BS are compared by an exclusive OR gate. The output of the gates shows whether the signs are identical or whether the signs are different. Same sign indicate that the magnitudes be added. Different sign indicate that the magnitudes are subtracted. When the magnitudes are added, A plus B are added, the result will be stored in EA. The carry out E indicates overflow. When the magnitudes are subtracted, EA equal to A plus B bar plus 1. There cannot be an overflow. If E equal to 1, then A is greater than or equal to B. So, A is greater than B and A is equal B conditions are checked. For both the conditions, result is in A and sign is in AS. Plus or AS equal to 0. If E equal to 0, then A is less than B. So, A equal to A bar plus 1 and sign AS equal to A bar. Thank you.